The first and second table that also do not have matching columns will also be displayed. So let me do that now. Let's right click on the table and go query tool. Okay, so what I'm going to do, I'm going to select all the columns. I'll do select star, means get all the columns from the customer table first, table called customer, and I'm going to do a natural join. Because I've not specified what type of natural join, it will make it an inner join. So if I wanted it to be a left join or a right join, I will indicate that. But because I've not, Postgres will assume it to be an inner join. So I'll do a natural join on the second table, which is the payment table. That is basically it. The query is completed. So what should happen? It will return columns from both tables. Let me run that so you can see. So it has returned over 14,000 records from both tables. So this query here is basically the same as an inner join. All right. So if I was to modify this, it will to an inner join, it will give me the same result. Say for example, I do select star from customers, okay, and I do an inner join, on the payment table using the customer ID, because customer ID is a column that is present in both tables. So if I execute this query, it should give me the same output. All right, so this is the first query here for the natural join, which, because I've not specified what type of natural join, it makes it an inner join by default. This query also can also be written as an inner join. If I was to write this as an inner join, it will give me the same result, the same output of over 14,000. So let me run this and you can see that. If I execute, look at here, it should show over 14,000 records. If it doesn't, then you see that it's shown over 14,000. So it's giving me exactly the same output. The convenience of using the natural join is that it does not require you to specify the join clause, because it uses an implicit join clause based on the common columns. I would be cautious using natural joins, because sometimes it can give you unexpected results. All right, so let me show you another example of how you can get unexpected results. So I'm going to pick two other columns here. I'm going to use two tables. So I'm going to use the city table and the city table here and the country table. I'm going to perform a natural join and you'll see what I mean by unexpected result. So I'll start with a select statement. I'll do a select and it will be star from city, which is the city table here, and I'm going to do a natural join with the country table, which is this table here. So if I run this, you'll be surprised at the result. You get something probably you didn't expect. So let me run that. As you can see, total query runtime, 0 records retrieved. But it's displayed the names of the columns, but no rows. The reason the query result is empty is that both tables have a common column name called last update, which cannot be used for the join. However, the natural join clause, this one, just uses the last update column. Okay, so you can see what I mean by you can sometimes get unexpected results. In this lecture, I have explained how to use the natural join to retrieve data from multiple tables. Thanks for watching and bye for now.
Hello and welcome. In this section, you will learn how to use the PostgreSQL aggregate functions. What are aggregate functions? Aggregate functions are used to perform a calculation on a set of rows and return a single row. So when you use aggregate function, the output will always be a single row. Aggregate functions can be used in a select statement. They can be used with the having and group by clause. When you use aggregate functions with the group by clause, the group by will first divide the result set into groups of rows, and then the aggregate functions will perform a calculation on each group. So in this section, we'll be taking a look at the basic aggregate functions that you'll find in PostgreSQL and also in other relational database management systems. So we'll be covering the AVG, which is used to return the average value, the count, which is used to return the number of values, the max, which returns the maximum value, the min, that returns the minimum value, and the sum, which returns all or distinct values. So I'll be taking you through each of these basic aggregate functions in separate videos. Hello and welcome. In this video, you will learn how to use the PostgreSQL AVG function to calculate average value of a set of rows. The AVG function is basically used to calculate the average value of a numeric column. What that means is that the column within the table, the rows within the table that you are applying the AVG to, that column must be a numeric column in data type. The AVG is one of the most commonly used aggregate function. It can be used in a select statement with a group by clause and also with a having clause. So let's take a look at the syntax. AVG also ignores null values. So whereby you have null values in a set of rows that you are applying the AVG function to, it will ignore the null values. So this is what the syntax looks like. You basically indicate the name of the function, which is AVG, followed by the column you are applying the function to. I'm just loading up the PG admin. When you load up the PG admin, you may get a prompt like this saying you are currently running X version, and it tells you the current version, because this pgadmin tends to be updated fairly frequently. So if you get this pop-up, do not worry, you can upgrade it if you want. But I'm going to leave it for now because it's not going to impact on the course. So I'm just going to click on the X to get rid of that, and I'll upgrade it at my own convenience. So first thing you do when you're logged into the pgadmin is to log in to the Postgres server if you haven't previously saved your password. So click on the plus and click on the plus again, and you get a prompt to pop your password in. So once you've entered your password, you can save it if you wish to do so. That way it doesn't prompt you all the time. And then click OK. And once you're logged in, it will tell you the server is connected. You get this message here. And then you expand the database. Let's see what data. I currently have 3 databases. So the database I'm going to apply the function to is this DVD rental. So right click on that and click on Query Tool. The query tool basically contains the editor where we'll write our code. This is the editor, and this is where the output of the result of the query will be rendered. And this here, you can resize it if you wish. If you want more space on the query window, just resize that. All right. So you can see also here on the title bar, it's got the name of the database that you are executing the queries on. So it's got the DVD rental, which is this database here. So any query I write will execute against this database. So I'm going to do a quick query on a table within this database. So if you expand the schema, you will see the public schema. And within the public schema, you will see a list of objects. So we want to click on the tables object. That will give you all the tables for this database. So the table I want to look at is this table here called film. If I click on the plus sign, we can see the columns. If I click on the plus, so these are all the columns for this table called films. So before I actually apply the AVG function, I like to run a quick query on the table to see the columns. So here's a simple query. Just select statement. The asterisk means it will retrieve all these columns and the rows from each of the columns. From here indicates the table is getting the columns from. Name of the table is film, which is this one here. So I'm going to execute by clicking on this lightning bolt, and that will give me output in here. So it tells me 1,000 rows were retrieved from this table. So I've added a block of query here, this block here, and what this query is doing basically is going to find the average replacement cost. I've got a column here called replacement cost, so it's going to find the average, and I'm enclosing this AVG function inside a round function. The round function is basically going to round it up, round the result to 2 decimal places. You notice here, I'll put a comma and I'll put 2. That means it will round the result in 2 decimal places. And this will be the column that will be outputted in the result here. So I have a temporary column called AVG underscore replacement cost. And under this temporary column, it will give me the average for this column. So let me execute that by selecting this and clicking on the lightning bolt, and that will give me the average. There you go. So I've got 19.8. You can see it's rounded to 2 decimal places because I've used the round function to round it to 2 decimal places. So this is a basic simple example of using an AVG function. So in this simple example here, I've used the AVG just to compute the average on a column. So I'm going to show an example where I'm going to use the AVG in combination with the group by clause. When you use AVG with the group by clause, the group by clause will divide the results into various groups, and then the AVG is applied to those groups. So I'm going to show you how that works now. So I've added the query here. So in this example query here, I'm calculating the average value of a group. So I'm using the AVG function with the group by clause. So what's happening here, the group by clause will divide the rows of the tables into groups. Then the AVG function will be applied for each group. So what I'm doing in this group, in this example here, I'm calculating the average amount paid by each customer. Okay, so let me execute this and you will see it will output. So you can see here, because of the group by, we're able to group we are able to divide the rows of the table into groups, and then we apply the AVG function. That's why we're getting this result. So you can see the AVG amount on here on this side applied to each of the groups. So I've also used a table join. So you see the inner join here. Joins basically allows you to relate data in one table to data in another table, and I'm using an inner join here, basically which I'm using to join the customer table to the payment table. So I've got a table called customer. If you look in the list of tables here, there's a table called customer, and there's also one called payment. So this is what I'm doing here. I'm joining the customer ID from the customer table to the customer ID on the payment table. And then once I've joined them, I'm using the group by to divide them. I'm also using an order by. I'm ordering by the customer ID. So that's why we have this output here. So I've illustrated how to use an AVG function with a basic select statement and also with a group by clause. Next, I'm going to show you an example how to use AVG with the having clause. So here I've got a query I've added on using the AVG with the having clause. You can use the AVG function in the having clause to filter the group based on a certain condition. For example, all the customers, I can get the customers who paid the average payment bigger than $5. You can see here, say greater than. So if I wanted to get all the customers who's paid larger than $5 US, I'm using the greater sign here to indicate that. I can use the AVG with the having clause. So let me execute the query and you'll see what I mean. If I click on that, and that will give you can see the output is returned 20 rows. Notice here I have used the $2_char expression. Basically what that does, it is used to convert the timestamp. It can convert the timestamp. It can also convert an interval, an integer, a double precision, or a numeric value to a string. So you usually, what I'm doing, I'm just converting a value to a string using the $2_char expression. So this is how you use the AVG in combination with the having clause. You can also use the AVG with null values. Basically, a null value is a value that is unknown. So if you are applying AVG to a column that contains null values, the AVG will ignore the null values and compute based on other values, other numeric values within the column. So that's it for this lecture on the AVG aggregate function. Thank you for watching and bye. Hello and welcome. In this video, you will learn how to use the PostgreSQL count function to count the number of rows in a table. What does the count function actually do? The count function basically returns the number of rows that matches a specific condition of a query. So let's take a look at a typical syntax for writing a count function. So this is what it looks like. So within the select statement, you indicate the count function followed by the table that you are performing the count operation on. Notice that inside the parentheses here, we've got an asterisk. What the asterisk means basically is that when you use the asterisk inside the count parameter, that means you're counting all the rows from all the columns within the table. If you don't use the asterisk, you can be specific. So you can actually specify which column within a table you want to perform the count on. If you don't do that, then the asterisk will perform the count operation on all the columns and rows within that table. So I've added a very basic query here to perform a count function. So we're using the select statement followed by the count function, and we are counting because we put an asterisk in there. That means it will count all the columns from this table called film. Okay, so all the columns, it will return all the rows from all this column here. If I can be specific and remove the asterisk and just pass in the name of the column. So I can pass in maybe this column and say, give me the count. But because I've used an asterisk, it will be applied to all the columns. So let me execute this so you can see the output. And it will give me, you can see it's returned a count of 1,000. So I know I've got 1,000 records in this table called film. I've added another query here, and basically a more specific query. So what I'm doing in this query here, I am getting the number of drama films with this query. So I'm being specific here. So I'm selecting a count. Okay, so it's going to count all the drama films from the film table, and I'm joining the data from a table called film category, which is this table. So, and then I'm using the film ID, using that from that table, and I'm doing an inner join from the category table. So I've got a table here also called category. Okay, so I'm getting this ID, category ID from the category ID from the category table, and then I'm using a where clause as a filter, where the category is 7. So it's going to look for an ID that matches that category ID of 7 from this category table. Don't forget, I'm joining these two tables. I'm joining the table called film category, and I'm using the film ID from the film category, and then I'm using the category underscore ID from the category table. So this table here is the category table, and if I expand that, you will see that the category table has got a category ID, and I've also got a film category. All right, so there's a film category, which is this, which contains a film underscore ID, which is this, and there is another table called category. If I expand that, and within this table called category, we've got a category ID. So I'm using the category ID from this category table and using the film ID from this film table. So I'm joining data from these two tables, and then I am using the where clause to filter the data, so it will only return the data where the category ID matches 7. So let me execute that query and you will see the output. So you can see it's giving me 62. So there are 62 films, okay, that matches this criteria. So do I know that I've got 52 drama films that matches the criteria I have set. So this is another way you can apply the count aggregate function. The main function of the count is to count. It gives you a total count of a row based on the criteria you have set in your query. I have added another query here where I have used the count function with a distinct keyword. The distinct basically is used to remove duplicate. So wherever you have duplicate, the duplicate will be removed and the function will be performed only on the unique values. So I've got a table here called payment. So let me just see. Yep, I've got a table here called payment. So that's what I am applying the count to. I only want the amounts that are distinct. Before I actually run this query that includes the account, I want us to see what we've got in this table first. This table called payment. So I'm going to run that query first so we can see if we can spot the duplicate values. Okay, so you can see here where this query here, I'm doing it on the amount. You can see this is the amount here. We can see a lot of duplicates. You can see 799, 799. You got a lot of duplicates here. So by using the distinct, it will only show one instance of a duplicate number. That's why we're using the distinct here. So it's going to skip anywhere there are duplicates. You can see we've got a few duplicate values. You got 4.99 there, 4.99, 2.99. So you got, quite a few duplicates here. All right, so now that you've seen what the table contains, let's run the function and click on that. And you can see it says returns a value of 19. So it's done a count based on the unique values. By using distinct, it will only count the unique values. So I've got another example I've added here. This time I'm using the count function with a group by clause. So I'm using this to get the number of payments by customer. All right, using the group by clause. And what the group by clause is going to do is going to group the payments into groups based on their customer ID. I've specified it here based on the customer ID, and once it's done that, I will then use the count function to count the payments for each group. That's basically what this query is going to do. So let me highlight and execute. So you can see here the group by has been used to separate the payments into groups. So it groups the payments into group based on the customer ID, and then I've applied the count function. So we can see here the customer ID is this, and this is the count, and so on. So the counts are on this side and the customer ID is on that side. So that's how you use the count in combination with a group by clause. So we have seen how the count function works with a group by. Now I've added a query here, this block here of code that will illustrate how to use the count function in combination with the having clause. So when the count function is used with a having clause. It is used to apply a specific condition to the groups. You can see I've used, when you're using a having, the having clause usually comes after the group by clause. So here we're using the having clause to apply a specific condition to groups. So for example, here I am returning the customers who have made more than 40 payments. Okay, that's why I've used the greater than sign. So let me execute the query. I'm just going to highlight that and click on the lightning bolt, and that will, so you can see this is what has been returned. So it matches the criteria I have set. So it has returned customers who have made more than 40 payments. So that's basically how you use a count function in combination with a having clause. So in this lecture, I have explained how to use the PostgreSQL count function to return number of rows in a table. Thanks for watching. Hello and welcome to this video. In this video, I will be explaining how the PostgreSQL max function works. The max function basically is an aggregate function used to return the maximum value in a set of values. So let's take a look at a typical syntax for expressing a max function. So this is what the syntax looks like. You start with the word or the name of the function itself, and then inside the parentheses is where you enter the expression. The expression could be a column within a table. So let's take a look at some examples of how the max function works. I have added a very basic script here just to show you how the max function here works. So in this example, the max function is used to return the maximum replacement cost of films. All right, so the column I am applying the max function to is to a table called film, which is this table here, and within that table, the table has a column called replacement cost. So this is the column this is what is going to be the expression. This is what the function is going to compute on. So let me run this query and you can see the output. So that's the value. So this is the maximum replacement cost for the film. So once a film is lost, say someone loses a film or something, this will be the maximum replacement cost. I've added another query here, this block of query here. Basically what this query is going to do is going to find out the maximum replacement cost for a film. So if I wanted to get the films, I'm trying to find out here all the films with their maximum replacement cost. So I'm using the select here to select the film ID, which is this column here. Selecting the title. So I'm selecting two columns from the film table where the replacement cost, which is this column, I'm using which equals to I'm using a subquery here. So we're getting the result of one query and using that in another query. And then the second query here, we're using the max function based on that output, selecting the max function based on this replacement cost from the film, and we're ordering it by the title. So let's check this out. I'm going to highlight that and click execute, and that will give me, so this is it gives me a total of 53 rows, which shows the film ID and then the title. So with this query here, I told you I used a subquery. So the subquery returned the maximum replacement cost, which then used by the outer query for retrieving the film's information. So we did the first query. What the first query did is to return the maximum replacement cost, and then we use the outer query to retrieve the film's information. So when you're using a subquery, to always return the output for the outer query. So we did the calculation first, and then we did this bit here. We selected this query, we ran this query. Hence we have the output for the film ID and then the title, because this query here is computed first, which is the inner query, and then the outer query is computed. That's why the result here is showing the outer query, but we've already done the calculation using the inner query. I have added another query here, this block of query here, again just to go over how to use the max function in a subquery to get other related information. So in this example here, I am using the information together with the maximum payment. All right, so I'm using a subquery here. So what we're doing here, the subquery gets the maximum payment, and then the outer query selects all the rows with the amount that is equal to the maximum payment returned from the subquery. All right, so in a subquery, the outer query is usually the first one, and this one here is referred to as the inner query. So I'm using the way I've used the query and the subquery here. The inner query, which is this one here, is used to return the maximum payment. All right, and then the outer query, which is this one here, selects all the rows with the amount that is equal to the maximum payment returned from this subquery here. So let me execute this block of code and you can see the output. The reason I keep highlighting this is because I've got other queries on the editor. I don't want them all to execute, so I have to highlight the one I want to execute. So I'm going to click on that, and that will give me, is returned 8 rows. All right, so that's what is, I've got 8 rows here. So that's how you use the max function in a subquery. I have added another block of query here, this query here, basically to illustrate how to use the max function with a group by clause. So what I'm doing here, I'm getting the maximum value per group. All right, so the query is doing here is going to get the largest payment paid by each customer. So we're using the group by clause to group the customers by their ID, and then we are using the max function to apply to those individual rows grouped by the IDs. So let me highlight this and run this query, and you can see that each customer ID will have the maximum amount. You can see here, this is the max function, and this is the customer ID. So that's how you use the max function in combination with a group by clause. I'm going to add another query which will illustrate how to use the max function in combination with a having clause. when you are using a having clause, the having clause is used after the group by clause. So I've added this block of code here to illustrate how the max aggregate function works with a having clause. So what this query is doing basically is that we're using the having clause to apply a filter for the whole group. So we've already used the group by to group the customer IDs into a group. We're now using the having clause to apply a filter for the entire group. So what this query will do is going to select only the biggest payments paid by each customer, and the biggest payments are greater than 8.99. all right, so we find out the biggest payments paid where the payment is greater, so the payment has to be greater than 8.99. So let me highlight and run this query, and we can see. So right, so this is it. So this is the output here. So we've got, it has to be 8.99 or more, not less than. So you've got 8.99, 9.99, and so on. All right, so it's got to be greater than or equals to 8.99. So that's basically how you use the max function in combination with a having clause. And when you're using a having clause, usually there is a group by already present. So the having clause is used to filter, to apply a filter to a where a group by clause has already been used. So that's it for this lecture. In this lecture, I explained how to use the PostgreSQL max aggregate function to find the maximum value of a set of values. Thanks for watching, and bye for now. Hello and welcome to this video. In this video, I'll be explaining how the PostgreSQL min function works. So the way the function works is opposite to how the max function works. The min function basically is used to return the minimum value in a set of values. Let's take a look at the syntax for expressing or writing a min function. So inside the select statement, you add the function, which is min, and then in the parentheses is where you specify the column you are applying the function to, and then you indicate the database table. So let's take a look at some examples. So this is a very simple example here. We're basically applying the main function to a table called film, and inside that table we are applying it to a column called replacement cost. So we want to find out what the minimum replacement cost will be if a film is lost. So I'm just going to highlight that and click on this bolt here, lightning bolt. So it tells me here that the minimum amount is $9.99. So that's the minimum replacement cost. I've got another example here of using the min function in combination of a subquery. So we're using a subquery here. Subquery, basically the way the subquery works is that it uses the result of the inner query. Once the inner query has been executed, the outer query will now work on the result of that query. So we've got two select statements here. That's why it's a subquery. This is the first one, which is called the outer query. So we're selecting the film ID, the title, which is film ID title from the film table, where the replacement cost equals to. So basically what it's saying is that when in a subquery, the inner query is executed first. So what it will do this block of query first, it will do a select on the replacement cost, which is this column here. So we are applying the main function to this replacement cost from the film table. We're ordering it by the title. Once that result gets computed, then the output of that result is not displayed here. This outer query here will now use that result and then select the film ID and the title from the output. Okay, so if I run that now, you will see the output based on, you can see here it doesn't give you any minimum value. What it's giving you here is the film ID and the title. All right, and because we've already, this output here has already used the result from the inner query to perform the main function, and then it passed the result onto the outer query, which has now displayed this output. Again, I've got another simple query here. This query, the queries I'm using here is identical to the queries I used in illustrating the max function. So a lot of it is the same. All I'm changing is the name of the function. Again, here, this is a typical subquery where we use the result of the inner query and for the outer query. So here we have two select statements. The first one here is what is known as the outer query, and this one here is what's known as the inner query. So we do the way the subquery works. It does the inner query first. So it will select the amount, all right, and then apply the main function to the amount. So once it's applied the main function to the amount, we're referring to this, there's a table here called payment, sorry. We're working with this table here called payment. If I expand the columns of the table, there is a column here called amount. So we are applying the main function to the amount from this payment table. Once that has been done, it doesn't output the result here. It passes the result onto the outer query, which then uses it to select all the columns from the payment. So when I output this query, it will show all these columns from this payment table. So let me highlight it, and then you can see that. Give it a few minutes. So you can see here all the columns of the table called payment is represented here or in this output. Okay, because we've used the result from the inner query that did the main function and passed it on to the outer query, which then used this query here by selecting star from which returned all the columns and rows from the payment table. So that's how you use the main function in combination with a subquery. So here I've got a simple example here of how to use the main function in combination with a group by clause. So again, I'm selecting the customer ID from the payment table, which is this payment table here, and we've got the customer ID, and I'm applying the main function to this column called amount from the payment table, and then I'm grouping it by the customer ID. So the way this will work, the group by will split all the rows according to the customer ID and then apply the main function to that. So let me run this query and you can see what I mean. So there you go. So it has split this group by here, has split all the customer ID here. So this, if I expand this, you see this says customer ID. So split the customer ID into their own groups and then apply the main function to each of the group within the customer ID. So that's how you use the main function in combination with a group by. Next, I'm going to illustrate how you use the main function in combination with a group by and a having clause. So this is a query here that includes a main function being used in combination with a group by and a having clause. You can see the group by. So the group by here is by the customer ID. So this query again is identical to what I use in the max, illustrating the max function. I've just changed the name of the function. So what the having clause does basically is filter the group whose minimum value matches a certain condition. And the condition I've set here is that the minimum value must match this condition, which means less than 8.99. All right, so let me run this query and you can see the output. So it will return anything that is less than 8.99. There you go. All right, so that's basically how you use the main function in combination with a group by and a having clause. Many thanks for watching and bye for now. Hello and welcome to this video. In this video, I will be explaining how to use the PostgreSQL sum function. The sum function basically is used to calculate a sum of values or distinct values. So when using the sum aggregate function, it will return the sum of values or distinct values. Distinct basically means unique. So whereby you're using it with distinct values, it will remove duplicates. Let's take a look at the syntax. So this is what the syntax looks like. You start with the name of the function, which is sum, and then you use distinct to indicate that you are applying the function to a distinct value within a column. When you're using the sum aggregate function, it ignores null values. So it means the null values are not considered in the calculation when using the sum function. A null value basically is a value that is unknown. You don't know the value. That's why it's referred to as a null value. I have added a block of code here. So this query here basically is illustrating how the sum function works. I've also used it with a group by clause. So what this statement is doing here is using the sum function to calculate the total length of films grouped by the film's rating. All right, so I'm grouping the film by their ratings and then applying the sum function to each group, and then I'm ordering it using the order by clause by the rating. So it's a very basic query. So let me execute so you can see the output. So this is it basically. So we are ordering by the rating. So this is a rating and this is the sum. So we're using the group by to split it into different types of ratings. So we've got the G, PG, these are the ratings which have been split using the group by, and then I apply the sum function to each of the groups, and that's the output. I have added another block of query here. This block here basically is slightly similar to the previous query. What this query is doing here is going to return the top 5 customers who paid the most. You can see I've used the limit here keyword. That means it will limit the rows to the top 5, and I'm ordering it by this column here. So basically this is it. I'm selecting the customer ID from the payment table. I've got a table here called payment. So if I just expand the list of tables, You can see here I've got one called payment, and I'm using the amount. I'm applying the function sum to the amount column, and I'm going to use an alias table. So it's going to output it as total. Total is an alias. I've used the alias by using the AS, which indicates when the output is done here, it will have this label on the column. This is just a temporary label on the column. So, and I'm getting the details from the payment table. I'm grouping the customer ID. So what the group by will do, it will split the customer by their ID and then order by this column here, this column I've used here, in a descending order, and I'm limiting it to the top 5 customers. So let's check that out. I'll highlight and run that. So it should only output 5 rows. You can see here it's giving me 5 rows based on the customer ID. So I've got the customer ID column. If I expand that, you can see customer ID, and then total, which is this column, alias column I've used here. So that's basically how you use it with a group by. So next I'm going to show you how to use the sum function in combination with a having clause. So when you use it with a having clause, you also have to have the group by involved. So I've added this block of query here, and basically what that query is going to do is going to filter the sums of the groups based on a specific condition. So I'm using the sum function in the having clause. You can say the sum here, I'm using it in the having clause, and I'm applying that function to the amount column. There's a column here inside the payment table called amount. That's what I'm applying the function to, and using a certain condition. The condition is where the amount is less than $200. So this query here will return only customers who paid more than $200. So let's check this out. I'll highlight the query and click on the lightning bolt, and that will output. There you go. So it has returned 2 rows. So there's only 2 rows that matches the criteria I have set of customers who have spent more than $200. You can see this customer here spent 211. This customer spent 208. So that's basically how to use the sum aggregate function. Thanks for watching, and bye for now. Hello and welcome to this section on analytic functions. Analytic functions are also referred to as window functions. What are analytic functions? Analytic functions are functions that will compute an aggregate value based on a group of rows. They are similar to aggregate functions, but the key difference between analytic functions and aggregate functions is that, unlike aggregate functions, they can return multiple rows for each group, while aggregate function returns a single result. So that's the key difference between a window or analytic function and an aggregate function. The term window basically describes the set of rows on which the window function operates. So a window function will return a value from the rows in a window. A window function also performs a calculation across a set of table rows that are somehow related to the current window. So just to summarize, a window or analytic function will compute an aggregate value based on a group of rows, and we can return multiple rows in comparison to aggregate functions that will only